All right, as we continue on section 9-1, we're now going to look at our strategies, the undoing strategy, and solve quadratics this way. So you can use the undoing strategy to solve for quadratics that only have a single x squared in the equation. So remember, a quadratic means your highest power of x is a 2. Like a parabola makes a quadratic. So if you have an x squared, it's a parabola, and it's a quadratic. And notice these two problems only have x's, no other. They have these x's that are being squared, no other x's outside of that. So when you have that x that's being squared, no other x's outside of that, you can use our Pemdas backwards strategy. So again, I'm going to write Pemdas backwards arrow here. And so the first thing I'm going to do is undo addition subtraction. So I see this minus 5 here. I'm going to get rid of that first by adding 5. Now you may say, hey, Mr. Lubis, there's a plus 3 here. I'm going to get rid of that next. Well, not so fast, my friend, not so fast, because we have this squared here. And this squared is protecting the 3. So we're saying, hey, buddy, if you're going to protect the 3, I'm going to get through you first. So we're saying, all right. So we can't undo this plus 3 because it's being protected. There's no multiplication division. So now I'm going to undo the exponent. And the way I'm going to do this exponent here is the opposite of square is to take the square root. And so what happens is when we take the square root, it cancels out the square. So the square and the square root cancel each other out, and we're left just with what's underneath, x plus 3. And then on the right-hand side, since we wrote that square root, we're trying to say to ourselves, what times itself equals 9? Well, 3 times 3 is 9, but also negative 3 times negative 3 is also 9. So you must put plus or minus 3 here. Anytime you write the square root, you always need to put plus or minus. And so what we're going to do now is then split it into two separate problems. X plus 3 equals positive 3. And then since it's minus 3 as well, plus or minus, it'd be x plus 3 equals negative 3. And then we're going to solve two separate problems. So we'll subtract 3. 3 minus 3 is 0. I'll subtract 3. And 3 minus 3 is negative 6. All right, continuing same idea here. We have that x squared, there's nothing else outside of that. So I'm going to undo the addition subtraction. So I'm going to minus 6. And 15 minus 6 is 9. Again, I can't do that minus 2 yet, so I'm going to undo the square with a square root. So that would give me x minus 2 equals plus or minus 3. And again, I'm going to break it now into two separate problems. X minus 2 equals positive 3, and x minus 2 equals negative 3. And so we'd add 2, and we get x equals 5. And then we would add 2 again, and get x equals negative 1. All right, I want you to try this one on your own. See what you get. All right, so the first thing you should have done is added 2. And so you get x minus 5 squared equals 16. Again, I can't undo that minus 5 because it's being squared. So then we take the square root of each side. So we'd have x minus 5 equals, what times itself is 16? 4, but also negative 4. So plus or minus 4. And then I want to break it into two separate problems. X plus 5 equals positive 4. X minus 5 equals negative 4. So then we add 5. So one answer would be x equals 9. Add 5, and x equals 1. We can also solve radical equations by using the undoing strategy. So radical equations are like not surfing. They're not radical, man. They're not these surfing equations. They are the equations with the square root symbol on them. And again, we're doing the Pemdas backwards is the strategy. So to undo addition, subtraction, there is subtraction of 1, but if you notice, that's being protected by the square root. So I can't undo that right now. So I'd go to the next one, undo multiplication, division. In this case, I have this 3 in front that's being multiplied, so I'm going to divide by 3. And that's just going to cancel the 3. So I'd have the square root of 2x minus 1 equals 5. I want to now undo the exponent, so square root's an exponent. To undo a square root, I'm going to square. The square and the square root cancel out, so we're left just with what's underneath there, 2x minus 1. And then 5 squared means 5 times 5, which is positive 25. And now I'm going to kind of start back over here. Now I'm undoing addition, subtraction, so I'm adding 1. 2x equals 26. Divide by 2, x equals 13. All right, for example 7, same idea. Undo addition, subtraction first. Now the difference here is that this minus 3 is outside, so I can undo that first. And then I'm going to undo multiplication, division. So this 7 is being multiplied, undo multiplication with division, so I'm dividing by 7. Again, it's only canceling the 7s. I still have the square root of x plus 1 around it. And 21 divided by 7 is 3. Now I'm undoing exponents. So to undo a square root, I'm going to square each side. The square and the square root cancel out, so we're left with x plus 1. And 3 squared means 3 times 3, which is 9. We're going to subtract 1. You get x equals 8. All right, try this one on your own. All right, hopefully you got it right. First thing you would do is subtract 4. And then we'd undo the multiplication, division, so we'd divide by 2. We then undo the exponent, so undo the square root by squaring. So that would cancel the square and the square root, cancel out. We're left with just x minus 7 on the left. And then 2 squared means 2 times 2, which is 4. And then we add 7. 4 plus 7 is 11. All right, so now it says, it's always a good idea to check your solution. It's always a good idea to check your solutions. To check solutions, you substitute your answers or answers in for x in the original equation. Let's check our answers for example 4. So example 4 was right here. X plus 3 quantity squared minus 5 equals 4. And we got answers of 0 and negative 6. So when I'm checking, I have to plug in 0 for the x, see if that makes a true statement, and then plug in 6 and see if that makes a true statement. So again, I'm plugging in 0 first. So that'd be 0 plus 3 squared minus 5 equals 4. And now I'm not doing anything other than simplifying each side. So following PEMDAS now, forward, inside parentheses I have 3 squared. 3 squared is 9. So 9 minus 5 is 4. And there was nothing to simplify on the right side. So does 4 equal 4? It sure does, so that checks out. Other answer we had was negative 6. So now we're going to see if that works. So if x equals negative 6, I'd plug negative 6 in. And so negative 6 plus 3 is negative 3 squared. Negative 3 squared means negative 3 times negative 3, which is positive 9. And 9 minus 5 is 4. So 4 does equal 4, so it checks out. All right, So this one, example 8, says solve algebraically and check your answer. So I want to get rid of, there's no addition, subtraction for me to undo because this is all underneath the radical. There's no multiplication, division. So I'm going to get rid of that square root first. So I'm going to square each side. And now this is a different type of problem. We haven't done one of these yet. We'll be doing these more coming up, where I have x squareds with x's. So whenever we have x squareds with x's, we have to set that equal to 0 to factor. It's been a little while since we factored, but I'm going to set it equal to 0, so I'm going to subtract 2x and subtract 3. And so that's going to be x squared minus 2x minus 3. And then remember our good old friend Sam for that Sam factoring. So what multiplies to x squared is x times x. What multiplies to negative 3, M stands for multiply, multiplies to negative 3, adds to negative 2. Is negative 3, positive 1. And then once it's factored, remember we said each factor equal to 0. So I add 3, and I get x equals 3 as one answer, and subtract 1, x equals negative 1 as a second answer. But it does say check your solutions here. So if we go to check these, I would say 3 equals the square root of 2 times 3 plus 3. And so as I go and do this, 2 times 3 is 6, plus 3 is 9. Square root of 9 is 3. So 3 does equal 3. That works. So I go to check the negative 1. I'd plug, so that was x equals 3. This is x equals negative 1. I would do negative 1 equals square root of 2 times negative 1 plus 3. And that would give me negative 2 plus 3 is 1. So square root of 1 is 1. But on the left side, I have negative 1. Does negative 1 equal positive 1? No, it does not. So therefore, we only have one solution here. It is positive 3. And the negative 1 is not a solution. And if we go to page 3, we'll see what that is called. So it says sometimes these are called extraneous solutions. So sometimes when you are solving radical equations, you will get an extraneous solution. An extraneous solution is an extra, first 5 letters of extraneous are extra solution you get when solving algebraically, but when you check the answer, it does not make a true statement. An extraneous solution is not a solution to the equation. Bottom line is, therefore, you must check all of your answers for radical equations. So these extraneous solutions only happen in radical equations. Therefore, anytime you have a radical equation to start, you should always check your answers.